Hi guys, welcome to my channel. So in this tutorial, we'll be looking at the integral from 0 to 1 of e to the x multiplied by the square root of 1 plus cotangent square of cosine inverse of e to the negative x dx. How do you evaluate this integral? So if you haven't subscribed to my channel yet, make sure you hit the subscribe button for more engaging and challenging integrals. So let's dive right into this integral. So let's use the U-sub. This one we can use the U-sub for this one. We can let u to be equal to cosine inverse of e to the negative x. So after letting u is equal to cosine inverse of e to the negative x, normally we take the differential. So let me refresh your memory. If y is equal to the cosine inverse of x, dy dx is equal to negative 1 all over the square root of 1 minus x squared. So I made a video about this one, how to differentiate inverse and cosine. So make sure you understand how to differentiate that before watching this video. So with this, we can do our differential. The u dx is going to be negative 1 all over the square root of 1 minus x squared. But here it is not x squared. It's going to be e to the negative x squared because our x here is e to the negative x. So that is 1 minus e to the negative x squared, like that. So du is going to be, but you have to multiply by the derivative of e to the negative x, which is multiplied by e to the negative x. The derivative of e to the negative x is negative e to the negative x. So in that case, du is going to be positive e to the negative x because negative divided by the square root of 1 minus e to the negative x squared dx. So in that case, our dx becomes the square root of 1 minus e to the negative x squared times du all over e to the negative x. We have to find an expression for e to the x, but then let's do the change in limits. The limit for x runs from 0 to 1. When x is equal to 0, what will happen to u? U is going to be the cos inverse of e to the negative x. The cos inverse of e to the negative xe to the negative x. So that will be like this. So that is cos inverse of 0. 1. Cos inverse of 1 is 0 because cosine of 0 is 1. When x is equals to 1, u is going to be the cosine inverse of e to the negative 1, which is just the cosine inverse of 1 over e. We just leave it like this. We can also find an expression for e to the x because we need to substitute out e to the x. When u is equals to cosine inverse of e to the negative x, that was our u. We can multiply here by cosine of u, or we can take the cosine on both sides, which is the cosine inverse of e to the negative x. So this one becomes cosine of u is equals to cosine inverse is just e to the negative x. So we have an expression for e to the negative x, which is cosine u. We have an expression for dx, which is here. And we have an expression for cosine inverse of e to the x. So we can take everything from the x world into the u world. So our integral now becomes the integral from the limits now change from 0 to cosine inverse of 1 over e. 0 to cosine inverse of 1 over e times this is e to the x. E to the x is e to the negative x is cosine u. That is cosine u. The square root of 1 plus cotangent square That is 1 plus cotangent squared. And cosine inverse of e to the negative x is u. I think I can clean this. Okay. And then multiply by dx. What is dx? Dx is right here. Okay, I'll write it again. That is 1 minus e to the negative x squared all over e to the negative x dx. But we know that e to the negative x is cosine of u. So our integral from 0 to cosine inverse of 1 over e of cosine of u, the square root of 1 plus cotangent square u times 1 minus, this is cosine u squared all over cosine u du. This is u. Okay. So our integral now evaluates to 0 to the cosine inverse of 1 over e. Cosine time cancels cosine. We are left with the square root of 1 plus cotangent square u times the square root of 1 minus cos square u times du. We know that cotangent square, we know that 1 plus cotangent square theta is equals to cosecant square theta. So you can just place it with cosecant square u, and 1 minus cosine square theta is equals to sine square theta. You can just replace this with sine square u. So our integral now evaluates to the cosine inverse of 1 over e. The square root of this one I'll just replace with cosecant square u times this one I'll just replace with sine square u du. This one evaluates to cosecant u times sine of u du. Cosecant is 1 over sine, 0 to cosine inverse of 1 over e. This one is 1 over sine u, that's cosecant times sine u du. So in the end, you are just evaluating the integral from 0 to the cosine inverse of 1 over e of 1 du, because the sine u's will cancel out. So in the end, our integral now becomes the integral of u, like that, from 0 to the cosine inverse of 1 over e. And that is equal to the cosine inverse of 1 over e minus 0, which is the cosine inverse of 1 over e. Therefore, our integral, the integral from 0 to 1 of e to the negative x, the square root of 1 plus cotangent squared, the cosine inverse of e to the negative x dx, is equal to the cosine inverse of 1 over e. And this is our answer. So that is how to evaluate this integral. So if you find that helpful, make sure to hit the subscribe button, like the video, and then I will continue uploading more challenging and useful integrals. I thank you so much for watching, and I'll see you in the next one. Bye bye.